Okay, I think we can start this webinar. Sorry. Hello, everyone, to the third in a row of six Fusion webinars. Today's topic is mechanical assembly strategies and product design with Fusion. If you are joining for the first time, this is the third webinar, as I said, and we will go over the agenda in a second. For those of you that you're not joining for the first time, you will already know the drill. This is the agenda for today's webinar. So a little bit of introduction about myself, knowledge point, Autodesk, and the trainer. And then we'll follow up with a little bit about the software and the upcoming webinar. My name is Anna Sotirovska. I work at Knowledge Point. I'll be your host, today's host for the webinar. I'm here to offer any support. I want to say that if at any point you have any questions, feel free to share them in the Q&A box, and expert trainer will answer them when appropriate. As I said, I work at Knowledge Point. So who are we? Knowledge Point, with over 25 years of experience in the learning sector, is the exclusive distributor for the Autodesk Learning Partner in the EMEA region. With this strategic partnership we have with Autodesk, we are committed to provide top-tier educational resources leveraging Autodesk technology. Today's webinar will be, the main focus will be in the mechanical assembly strategies and product design and creating the table vise assembly. As I'm not the expert on this matter, but here with us we do have the expert. Without further ado, I will pass the floor to our speaker, Cengiz Kurtoglu. He will introduce himself and take over the webinar. Cengiz, the floor is yours.
Thanks a lot, Anna, and welcome you all for the participant our third webinar. And today we will focus on mechanical assembly strategies and product design with Fusion. Well, normally we already talked about in our first webinar using a 6-axis robotic arm to get some joints, revolve joints, as a mechanical assembly. But in this webinar, I will focus all types of assemblies at the same time on the different projects. And we will check it out, product design with Fusion, because there are lots of different details in Fusion as a product design. At the end of this session, we will make render projects using table vise, or I have a surprise for you about the projects, and we will check it out, the render workspace also. Well, if you're a participant today, if you are your first webinar and this webinar, I'm Cengiz. I'm a mechanical design engineer, and I'm an instructor, Autodesk authorized instructor. I'm working with the Autodesk teams about 6 years, and I'm based on France. I'm from Turkey, and welcome you all from other countries. Today, we'll get a quick intro about the Fusion, just a quick intro. And after that, we will take a look different types of assemblies, particularly in the table vise, using the basics of parametric modeling, because we already discussed in our second webinar also the parametric modeling types. And product design workspace, there are some plastic rules using different types of plastic, and quick intro to render workspace. Well, what is Autodesk Fusion. It's basically a software that you can use the 3D design workspace, CAD, computer-aided design modeling, and also you'll have a chance to use this software using cloud-based. It's very handy to use your software using some web browser. It will allow to use directly on your Chrome, for example. And also, at the same time, you can use the manufacturing types to create your G-code on your software, Autodesk Fusion. And also, you can create different mechanical assemblies. After that, you can analyze your assemblies at the same software. You have a render, animation, and electronic design workspaces on Fusion. Well, if we switch off the design workspace, it'll all start with the solid modeling. We already discussed the solid modeling tabs in Fusion, but also there are different types of modeling. There are different types of approach to model your 3D design. For example, T-spline modeling. It's a NURBS modeling you can use on your Fusion software. And also surface modeling. It'll allow to create a tiny surface 3D parts you can use on your manufacturing or technical drawing types. And also sheet metal rules you can use on your software also. And after your 3D parts, maybe you have a 3D scanner, you can use Fusion as a mesh slicer, mesh modifier in the design workspace. There is a animation in this account of the Fusion. As you can see, there is there are different types of joints here, basically in revolve joints. We will see today. Render workspace, it will allow us to create high quality images and animations. It's very simple to get some nice image at the same on the same software. So it will be interesting to create your parts in 3D and then to create an image assigning some appearances. As you can see, there's a aluminum blue material on the appearances of these parts. After that, we can take a look our animation workspace. We already talked about on our second webinar. You can check it out on Knowledge Point YouTube YouTube profile. Well, in the animation workspace, we will create this mechanism in the robotic gripper mechanism. As you can see, there are at this point, it should be a revolve joint, and then for the servo motor parts, it should be a revolve point on there and here. After that, we have to create a link between these two sub-assemblies or the assemblies. It just simply we can say assemblies. Well, after we connected all parts as a revolve, you can get this mechanism directly. But it should be the dimensions. It's very important because I already create this mechanism using some technical drawings. Well, we will check it out on Fusion in our next slides. And also on Fusion, there's a simulation workspace. It's quite detailed workspace, because after you design a part on Fusion, you have access to assign a, for example, load on the or pressure on your parts, and you can assign some constraints for the points should be fixed. After that, we can create some results. Normally, Fusion creates a results, solve the solutions for the parts, and we can compare our results. For example, we will create a static stress simulation in our next webinar. After, we can compare two different parts. If I change the rib part, for example, the all mechanics on the parts could be changed. So it's very important to use the static stress analysis or other types of analysis. For example, shape optimization or topology optimization is a widely used study. We can create lightweight parts or structurally efficient based on your preferred conditions. There are some examples for topology optimization or shape optimization, or static stress parts for the in the second animation. We'll analyze all constraints, loads, materials on our next lessons. Well, also you have in this same software in Fusion, you have access to manufacturing fabrication workspace. If you want to create a mass-produced large-scale projects or just a small part, you have access all of them, like milling, 2-axis to 5-axis, turning, water jet, plasma, laser cutting, or additive manufacturing. You can create your own 3D G-code. After your 3D parts, you can create a G-code adapted to your manufacturing machine. Fusion have a library of the machines, and you can easily create your G-codes and bring your ideas to the real life as soon as possible. Well, also, we already mentioned in our previous lessons, webinars, drawing. Well, if you have to manufacture your parts, well, in general, you have to create a technical drawing to explain your details, the dimensions, materials, parts lists. You have access to create your drawings on Fusion, and also if you change anything on your 3D parts, the drawing will be updated after your authorization, and also your technical drawing could be exported as a PDF, DVG, DXF formats. Well, Also, Fusion have an electronic design module, workspace. You can create 3D PCB for your team, or if you are an electronic designer, you can access to create all libraries for the for PCB, for creation of PCB or library management, simulation, or mechanical designs. Well, after that, there are also a module, a workspace that I liked, that I preferred on the all of the softwares. Generative design. Well, in generative design, designers or engineers enter a design goals into generative design software, along with the parameters such as performance or requirements or materials, manufacturing methods, cost constraints. The software Fusion explores all possible permutations of a solution, quickly generating design alternatives, and it tests, it learns from each iteration what works and what doesn't. As you can see, it creates very different types of one parts. Normally, there are 6 or 8 parts. It should be a manufacturer, but with the one part, you can create, you can use additive manufacturing as you want. Well, let's switch off the Fusion. Before start the Fusion project, I would like to mention you can use Autodesk Fusion on your web browser directly. Just fusion.online.autodesk.com and launch Fusion 360, and then you can access all your projects, all your data, and you can design directly on the web browser. It's very, very quick way to access your projects, because it's not necessary to download Fusion on your computer, and you have access from directly on web browser. Now, let's start our assemble techniques, assemble principles. Well, now, as you can see, I have a rectangular shapes. In that type of the assembly, I just want to create a rigid joints. It should be stay on the same position. Well, it's quite important to create to assign rigid joints, because the mechanism, yes, we have to create types of different mechanism, but if the parts, the components has several parts on your projects, you can use rigid group or rigid joints. Let's see on Fusion. There's other examples we will see. Now, I just want to create a component, because after you design a part, Fusion, it creates in default bodies, body 1, body 2, and body 3. Well, if I change from there, right click in the body, create components from bodies. Now, the body changed to component. Well, as you can see in the browser, there's a component 1, and component has a own origin with respect to these parts. and have a bodies folder in there. I can move to these parts now in the 3D workspace. But these bodies, it cannot be moved. But normally, I don't want to move these parts. It should be a component, but it should be a ground place for me. So after I created a component, I just right-click to component and ground. After I hit the ground, it asked me capture or revert component position. Revert positions the same position in the axis of X, Y, Z. They remove to the first place. Capture position, as we can see, it stays on the X, Y, Z points. I did capture position. Now I try to move these parts, but I couldn't because there's a ground. As you can see, there's a red pin on there. Well, now I want to create components from these bodies, but there are some other ways to create components from here. After we finished our parts creation and modify details, I just want to create a new component. Yes, we already know if I right-click to body 2, create components from bodies, it worked perfectly. But I just want to use these parts of new component. Well, new component, it's asked me which parts do you want to create a new component. It's basically create a new component, but if I switch to from bodies in here, I can just select the bodies that I want to convert to components. From bodies, it's one selected. I hit the OK button, and now body 3, it creates any component. Well, now I want to create a joint. Well, how can I create a joint? I'll switch to this part. Well, how can I create a joint? It's very, very basic. After the new component parts, there's a joint icon. It's a G button on your keyboard. I press the joint, and there are just activated components, the last one, because I cannot create the first components, create the joints for the first components that we created, that we modified as a ground, because it couldn't be moved. It's like a bodies. And also body 3 is a body 3. It couldn't move. It should be stay on the position that he already positioned. Well, now it left one part. Basically, I want to, these points should be at the edge of these rectangular shape and should be as a rigid part. It couldn't be moved. Well, there are several ways to assemble these parts, these joints. I just want to mention these origin, as you can see, origin mode as a symbol. Well, when I close to this face, as you can see, for this face, there are some control points for my first, there are some snap points for my component for the first joint. If you hit and push and hold the control button, the icon will get the all control points. Now it could be easier to select what you want. If I select this XZ face for this part, I have to select, it could be easier to select these points because I know it should be exact same points on the other parts. Well, I'll try to hit the button for the first component, for the first snap, and then it'll go. Because you can select just one point, one snap point on your component. After you select it, it will be gone, and it'll appear other components, like other components. Which components is a component? I know this is a ground plane component, but also in the body tree, you can create a joints between the components and bodies, but for the just second component. Okay. Now, remember for my first point in here, and logically it should be here, but it's different. It's hard to select these parts, and also I just want to catch these sides of this face of the control points. Control points should be on this face. Well, after I moved my mouse here, I hold the control button, and easily it get the 9 points, 9 control points of this face. It's same logic. X, Z, axis plane of this face and this point, component 2. Well, it created slider mechanism, but the motion should be rigid. I'll switch to rigid, but I already select the flip sides on my last joint. I have to select these flip sides. Normally, you already get these parts after you select from here, first part, from here, second part. Well, it created a rigid, and it couldn't be moved after all. I'll try to move, but it works. Now, we just use the faces on the XZ plane, but now I'll try to use different approaches to create this at this same thing on the other side. Well, I hit the G button to create the joints. I remember now these are not components. It should be converted to the component. I generally use this trick from body tree, create components from bodies. It's easy and fast. I hit the G button, and now normally you already select these faces, but I will try to use other approaches. I can use this line, this edge, I click the control button, and there are 3 snap points on this side. Well, if I select on this axis, in x-axis, edge of the x-axis on the negative sides, it's selected. And now I'm coming back here. There are also an edge. I hit the control button, same logic. There are 3 points. I'm selecting last one of these points, and it's done. It created rigid. As you can see, it worked perfectly. Well, you can use these control points as you want. Also, you can use this side of the edge, also the last points for both of them, or these edge and the last points from here, and this edge and the last point here. It's all good. It's all done. You can use these types of control points. It's very easy, and yeah, you can use these approaches to create your mechanical assemblies, and it's not hard at all. Now we will switch the a little harder example or on our next lesson, next slide. Well, in this particular subjects, now normally I already use the edges or faces to get the points, snap points for my project. But in this example, there are no connection between these parts. It should be in between the axis, and I have to figure it out to create this assembly. Well, let's look at the Fusion. Well. Joint, origin. Well, as you can see in the front, there are no connection between these parts. Maybe there is a crank, there's a mill between the parts, but I have to create this mechanism from 2 of the parts, and after that there's a third component here. It should be be moved from the blue parts, the second parts. Well, okay, let's try. I'll erase the points, and now we have to create these joints. Now, as you can see, these parts are body. It couldn't be moved. If you want to create from bodies to components, you have to make the ground, at least one of them, on your assemblies, because if it's not a body on your projects, on the assembles, if there is no ground parts, it couldn't be moved. It couldn't be a response for your mechanism. Now, body 1, it's okay. The components is already ready. I hit the G button. We already use the origin mode as a symbol on the faces, directly to the faces. The points could be reached from the faces. But there are other types of origin modes, as you can see, between 2 faces or 2 edge intersection. Well, in this particular example, we have to switch to between 2 faces. between two faces, it's asks me plane 1 and plane 2. Well, for this project, I can create the origin between two faces as a plane. It should be intro in the inside of the parts, or this two sides of the parts. Well, I'm selecting inside of the body these sides and this plane as a second plane. Now, between the two plane, I have access several control points. I'm zooming out a little bit, and now, as you can see, in the circle, it captures, it snaps between the two plane. After I selecting the circle, and it creates a little joint origin between the plane for respect to circle. There are other points, other control points. You can press the control button and you can get the points as you want. But because, as you can see, I cannot select the circle. So I'll release the control button. I'm selecting the circle. For this first part, I already assign a joint origin points, and now I have to assign for these parts also. Well, origin mode, it should be passed between two faces, okay, plane 1 and plane 2. Same logic. I'm selecting circle, and it created a rigid motion, but I don't want to create a rigid motion. It should be a revolve. Voila. Preview motion. If you select the preview motion, you can see the parts. It's moving a bit with respect to axis. Axis we created with respect to joint origin. Well, there's a little trick from here. You can limit your motions. There's a joint motion limit icon here, minimum and maximum. You can assign your degrees directly here, or after you created these joints, you have access to assign your motion limits. Now, I hit the OK button. As you can see, we created a beautiful joint origin. It's very interesting, and the level of the assemblies, it's very easy to create, but you have to be attention about the faces that you selected, and then it's perfectly aligned in between the two faces. Well, now I need to move these parts to the center of these parts, but I don't want to get degrees. For example, is 27 degree. I just want to 0 degree. You can move from your mouse here, it's 0 degree, or sometimes it could be not easier in every time. Double click on your joints, and it will be reached as the right joints. You can modify the degree here, or you have a folder as named as joints, revolve 6 or revolve 1. Right click on your revolve and drive joints. You have access to change the degree directly. Now, I want to these parts of moved to directly here in the center of the bottom face of these parts. It should be at top of the second component. Well, now I'm hit the G button. It could be a simple origin mode. I'm moving these parts. As you can see, the bottom of these parts, in this phase, there are 9 points. I'm selecting control. I'm holding the control on my keyboard and hit the center of this phase. It's selected. Now I'm coming back to the top of these parts. I'm selecting the top of this blue component. It created a motion as a motion revolved. No, it should be rigid. Preview motion. Yeah, it works perfectly as I aimed to create these parts. Now I can move on here. And also, for example, we decided to modify the parts, the design of the parts. If I hit the Q button, press pull of the design, I can change, I can modify on my assemblies directly with respect to all joints. It's really, really handy to create these parts, and you have access to create your assembles, to modify your part on the same software, on the same interface. It's very handy and quick way to create your mechanism. Well, we'll continue our types of assemblies in our next slide. There is a pin slot motion. It's selecting. We can change the type of the joints as you can see. It should be moved as a slider here, the slot parts. My voice is echoing. I'll check it out quickly. And also between these parts, if you have a question, you can ask me. Just I'm checking the parts. If you have a question or if you would like to mention about some particular projects, particular points, you just ask me. Unfortunately, I already select the good parts of my speaker. I hope I'll try to speak more clearly. And now we'll continue to pin slots on the Fusion. There's different types of assembly. Well, pin slot. Now the motion should be revolved between the axis of this cylindrical part, and a slider should be here in the parts of the slots. Great, my voice is nice and clear, cool. We'll continue to our next example, pin slot. Well, as you can see, the component is already created as a component, the part of bodies. In general, in my projects, sometimes I created the projects very long time. I don't remember to the details of the parts. You can always check it out the browser. It could be say something about the project and also timeline. In here, I created a box primitive and sketch to slot parts and extrude to cut operation. And the component parts, I created a cylinder and the box and fillet. And the last one is pin slot. I can raise from directly here from the timeline. If I erase from here, it would be appear the folder as a folder. Or sometimes I just want to need to change, modify the type of the assembles, because sometimes very large assemblies need to be modified. I just want to switch, suppress features. I hit the right click on my icon, the last one, the last icon of the joints, suppress features. Now, in the timeline, there are no joints. If I change, it could be appeared on the browser also, but now I just have a component and I just have a bodies. So I'm hit the G button. I just want to select the bottom parts, bottom points of these parts. You can select the points of circles. We will try. For example, if I select the center of these parts, I move here. Well, there is a point for my centers also here. I'm selecting center of these slots, and as a default motion, it's created a type of rigid, but I want to change as a, for example, slider. If I select as a slider, no, it's not the moved, it's not the exact axis. I just want to slide. For example, x-axis, no, not at all. Y-axis, no. So there is a fourth one as a custom axis. If I select the custom, I have to say to Fusion this axis of orientation as a slider. Well, nice. I have reached to as a slider motion. It's just a slider motion. I cannot change. I cannot rotate the parts. Well, as a preview motion, yes, good. But I just want to rotate the parts while they are sliding this custom axis. Now I'm changing as a pin slot as a rotate. Well, now it asks me the rotate, the part of rotate. I'm selecting the x-axis, no. Y-axis, no. Z-axis, well, it get the good rotation as I want. But the slide axis, it's not true, X or Y. It should be custom axis. And the custom axis of these edge. Now, as a pin slot type, in the preview motion, it's rotating in the axis of the z-axis, and also as a slider, it's moving with respect to custom edge. Well, it's all done. Great. Now I can move as a slider and rotate here. I already mentioned about the joint limits, because when I arrived here, no, it's not working. The mechanism, it's not good at all, because physically it's not possible. Now I can assign a joint limits. For that, I have to pass to joints folder, pin slot, and right click, edit motion limits. When I click the edit motion limits, there are rotate motion and slide motion. I'm switching to slider motion minimum. Minimum of these parts. There's a little flag on there. As you can see, we can change the value as a millimeter, and a maximum value of these parts, maximum here, for example. Well, it should be arrived minus 30 and maximum 30. As you can see, preview limits, you can reach the parts. Now, I'm hitting the OK button. Well, it's quite good, and it's all done. Let's continue our next slides as a cylindrical joints. It should be easier after pin slot. Cylindrical, it's the same logic. It's, for example, slides on there and rotates for the y-axis. Erase these parts, these joints, and hit the G button, or the part is already designed the position that I want to joint. That I want to create the assembly. So you have different types of joints as build joints. Shift G on your keyboard. As build joints, you just select the parts and types of the motion. You can select your types of the motion. We have to say the snap point, for example, as a center of these parts. Well, it's not complicated at all, because the joints, the types of the joints, it's very simple. The logic of the snap points, it's quite important to get practice of yourself, and then you can create different types of mechanism as soon as possible. Voilà. Now, on our next slides, I have other planar ball. I just want to mention quickly, like a joystick parts, it should be planar ball, edit joint. In the type of ball, you have to select as a sphere, as a part of sphere, and then you get pitch and yaw action on the part, and then, as you can see, it could be moved as a joystick or planar. As you can see, the type of the joints, it changed as a plane. It could be rotate on the XZ on the y-axis, and also it could be moved as a planar face. It's very interesting. You can check it out on your on the different types of projects also. Well, I just want to mention before switch the other project. This is a universal joints mechanism. Basically, we already mentioned the 6-axis of the robotic arm in our first webinar. It was it have a 6-axis to basically in rotate, like you're using rotate joints. We could create universal joints for our for change the axis to add new axis of our parts. For example, these parts should be ground, and the first cube, it should be rotate, the first axis, and the second part of this cube, it could be rotate for the second axis, and then we will add other cubes for the third axis. It could be rotate, and also we will add a 5-axis for just simple universal joints. It's widely using in the industry, universal joints. You can just type on the Google for the examples of the universal joints. And now I want to explain the universal joints quickly in this design. Well, as you can see, the component, it's not moving. It's moving. It's a component. It's not assembles. The first part, it's a bodies. That is great. It's a shaft. But the other parts, it's not assembled. We have to assemble these parts. But I have a tips for you. Normally, 1, 2, 3. These 3 components should be rigid, should be moved together. So I have a tool for these parts, rigid group. It's very useful on this project because revert capture position, it's okay. I'm selecting the main parts as a cube and the other parts for the rigid groups. And now, if I change the position, as you can see, the rigid group, it's moving together. Well, this is great. And same thing for these parts. As you can see, if I add a joints, it should be moved together for this particular part, and I'm selecting rigid group for these 3 of the components, and now it's great. And the last one, these parts, it should be rigid group. Quickly, I'm selecting the parts, and then it's done. We can just begin from the first axis of these parts, It's basically should be revolve. I already designed the position should be assembled these parts. Now I'm using Shift G as a part for this cube and the body, for example. Now I'm changing. I'm selecting the snap point as a revolve, the type of revolve. Now, normally I don't have access to the inside of the cylinder, inside of the cube. But if I hit the control button and holding the control button, as you can see, I can select the snap point of the at the top of the cylinder. It's great. It's moving as I want in this y-axis. Cool. I'm continue to our second axis of these cubes and these parts. Now, if you want, you can select these parts. There's a component 1, 2, 3. I'm change the visibility of these parts. It could be easier to manipulate your software quickly. Now I'm selecting Shift G, these parts and any parts that we want. Same thing, revolve. Revolve could be any circle of this axis. It's very simple. You can select directly at the last point, last circle of this axis, or the inside of the axis, or the face of this axis. It's very handy. You can select as you want. For example, I'm selecting these parts and up and down. Great. So I have a 1 and 2 axis. Well, I'm reopening these parts. We already create as a rigid group, Shift G button, this cube and these parts, for example, same thing, revolve the last circle of these parts. Now I have a 3 axis of this universal joints. I'm continue as the cube. Well, I'm selecting these 4 last components because it will be easier to see. Well, same thing, Shift G, this cube and these parts, for example. Same thing. You can select the face if you want. Now, hit the OK button. We have a 4-axis, as you can see. Voila. And now I'm reopening the 4 parts, the last parts. We have to add our last component, last joints for 1, 2, and the circle of these parts, revolve. Yes. And if I hit the mouse very quickly, you should get noticed, or I don't have any edit joint limits, because yes, we can make an edit joint limits. I don't have a time for that, but you can make an edit joint limits. For example, from here, for example, it's a 90-degree, minus 90-degree to plus 90-degree, as you want. And after you create you assign your parts as edit joint limits, you will have a chance to exact position for your universal joints. For example, I'm changing as a driver joints. It's very cool and handy way to create your parts. And after that, for example, for our robotic parts, we have to find the exact angle for these parts. Now you can change as you want. Hit the up button. Now it's okay. I will continue to our next lesson. Next slides. We already seen these parts. I just want to mention how you can create these points, this gripper mechanism. Well, as we mentioned, there are revolve. It's the same thing like universal joints. You have to get the axis as a circle or the face as you want. After you assign the revolve for two of them between these parts, it should be components for all bodies, and for that one, as you can see, there's a pin, the red pin. It couldn't be moved. If I change the pin one, the assembly shouldn't be moved. Well, as you can see, the all joints works perfectly between these motion link, because there is a motion link between two of the gear as a same ratio of the spur gear. If I turn the first one, it should be turned the second one, it should be exact degree between of them. But you have to select the reverse, because if I change as a same rotation, it won't work. Well, for our next slides, there's a table-wise assemble. Let's have a look on our Fusion. I just want to mention these parts should be, for this part should be here, and this part should be here as a clamping plate, and it just should be parts for the rigid groups. We already mentioned. You'll get. I think you can understand quickly the basics of the assembled parts. Yes, I know there are several parts. It could be a little harder, a little complicated, but no, it will be easier to mention sub-assemblies, to mention part by part. Well, for this table-wise assemble, we have to start with the ground plane, because all parts could be change the position, because there's a components. Yes, I can get a base fixed body, right click and ground. That's okay. That's great. And now I continue to these all parts, because all little points, little parts should be screw, and the screw holder. I can assign a rigid group for these parts. Great. I'm selecting rigid group. I'm selecting capture position. For the first part, screw, handle, and the handle edge, and this screw holder, and also plain washer. It should be revolved, but it's okay. I'm selecting as a rigid group. It's done. Now, as you can see, it will be moved. Great. And also, there are other parts in here, which for these bottom parts should be moved after these wedges. And there's a cylindrical hole here to get joints between two of them. Well, I have a idea to get the joints to make these joints. Well, basically it should be joined as this line, this edge, and this edge. Yeah, this is an idea. It could be, but you can use other faces like this face should be here, or bottom face should be here. You can select these edges to these edges using control points. You can use whatever you want. It's very handy and quick to get information from the joints. Well, I'm selecting this edge from this edge. Control. I'm selecting, holding control on my keyboard, and it's done. The motion should be rigid. It's great. Same thing for this second part, G point, G point, and then it's done. Well, nice. And there is a clamping plate, should be here. Well, how can we do that? G, it's very simple. This circle should be here. It's basically it's like that, and the motion should be rigid. It's done. It's okay. And the other clamping plate, this circle G, this circle, but I selected wrong points. I modify as a erase these parts, erase these snap points, and selecting the circle. Now I'm selecting other parts. It's done. Motion, rigid, cool. Now, it's very simple. What should we do? These parts should be slide on this side of the base body. Well, there is a line, there is a face between two points. It could be edges. For example, there are lots of ways to make these assemblies, but basically I'm selecting these edges between two faces. As you can see, you get the edges. I hope you can see this particular edge. Control points. I'm selecting the control. I already selected. It's done. And in this faces, in this face, I'm selecting as a control points these parts. Right. But the motion should be sliding. Well, we are starting to make our parts cool. And now I have to revolve these parts, this circle, to that directly. Well, there is a point here. As you can see, this edge should be here. For example, G, it already selected the circle. Second circle, the motion should be as a revolve. It's okay. Hit the OK button. Now it's sliding and revolve. but there is no connection between the slider and revolve. Well, there is a tool to assign that. Which tool? Assemble motion link. It allows to define between the rotational or translational relationship between the joint degrees of freedom. There is a section view, section analysis for these projects. For example, here I'm working as a quite detailed. As you can see, there is a gap. It should be moved here, exact position. You can work on in details, but I positioned as a parts should be as positioned. Now I'm selecting motion link, capture position, slider, and or firstly revolve and slide. The distance should be between the threads. I created these threads as a 3 millimeters. So if the distance between the threads for each of them 3 millimeters should be a 360 degree. Hit the OK button. Now the assembly created as a motion link. If I slide, if I change the rotation, something like that, it will be moved as it should be. Voila. If you have a question, just ask from the chat. And on our last 10 minutes, I just want to switch the product design and the render workspace. Well, product design, you have access after you, as an extension, the product design extension, there is a plastic tab on your Fusion. And the advanced tools will be appeared after you have an extension as a product design. I just want to show you some examples. Voila. Now, in the plastic tab, you have some different types of creation, like snap fit. Because if you create a product design, for example, it should be electronic parts or smart device. The design should be closed as a, for example, snap fit. You can create different types of snap fit in this tab, in the plastic tab, or as you can see, there is a quite advanced level of the geometric pattern. As you can see, there's a tab for geometric pattern. The pattern with the different size or distribution, gradients across a face or the solid body, as you can see. We can check it out, the feature. For example, I already create a basic vase design like arc. After that, in the feature of the geometric pattern, you'll have a object size. You can create different objects. I already created as a cylinder, but you can change as a sphere. You have access different types of objects. Also, you can assign your specific parts of your type of your objects. After, you can change the object size, the limit 1, 2 millimeter to limit 5, for example. It changes, it's the gradients, it creates a gradients between the objects. In the center of the parts could be bigger, and the last parts, last edges should be smaller. And you can change the like we created in the pattern, circular pattern, rectangular pattern. You can change the object distribution type, spacing type, increments, U and V axis as a distance, and you can change the alignment. It's very handy to create different types of geometric pattern on the Fusion. In the yes, there is a on the chat. It's not only in plastic. We can use in solid also. Of course, exactly. You can change the type of the rules as plastic or metallic parts. It's very handy, and you already perhaps you already tried. Keep going if you have any question or comments about this particular workspace of Fusion. You just send us or ask us your comments. Well, the last part of this webinar, I just want to mention the render workspace, because we need to create our projects as an image time by time to add your, for example, thesis or projects or the promoting for your jury or your teachers or your clients. So we can assign different types of appearances as materials on the render workspace. Also, we can change the camera settings or environment settings, and we can modify or add some depth of field, focus point for your projects. Well, quickly take a look these projects, these chest parts. I already designed these parts on Fusion, and I assigned some appearances. You can access directly on Design Workspace. If you hit A button, Appearances, you can access the appearances, or if you want, you can pass the Render Workspace and selecting Appearances here, and then it will appear the library for Fusion 360 appearances. In this projects, I don't know these parts of the 64 parts should be component or faces, but if you need to change a face, you can change the apply to faces, and these faces should be different. Just drag and drop your points and you could be assigned. Now, after you assigned your parts, you can switch to skin settings. It's not complicated. It's a very simple, but the results is very interesting, very fast and photorealistic. As a environment, we have some environment library. You can change the different types of lights, soft lights, grid lights. You have to take a look for the difference between of them. Or there are some HDR photos, it's a real photos. You can assign, you can attach your custom environment as a HDR photos. After maybe you can create your HDR photos or just download on the web. But in this project, I'm assign a color as a solid color for the background, and brightness you can change as a lux meter here. Just selecting the different types of level, and ground plane you can select or deselect the ground plane as you want. And the reflection as a roughness, you can change the roughness of the parts. Well, camera, you can change the perspective. If you are a photographer or have a knowledge about the cameras, there's a focal length, exposure. You can change the as a units, the millimeter of the focal length, and the whole image could be changed here, isometric perspective, and now depth of field. Also, you can change the depth of field as you want. Just at the point as the center of focus, and the other parts of the center of focus could be blurrish. And the aspect ratio you can change. You can assign your value as an aspect ratio. The parts, here it's a 60 to 9. Decal, you can add your icon, your logo, and in Canvas render you can render it as you want after you have a high quality image, just to 400 pixel for 4000 pixels here. It's a very handy, and the render workspace could be work on your computer and also work on the cloud systems. It's very a quick way for me to create my renders. Well. Now I just want to mention, and also Anna will be mentioned about the webinar for our next webinar about the day. I just want to explain what will be in it. Mechanical simulation and analysis application in Fusion, and comparison of the static stress analysis of a bracket design. We will create these two of the designs, because as you can see, it's different. There's a rip design in the first one, and the second one there's no rip design. And as you can see, red parts, it's mentioned about the after the loads, it's a critical parts. We will discuss about these types of analysis, and we will create these parts. If you want to create for your own parts on your computer, you can go to our second videos on the YouTube knowledge point YouTube videos. You can check it out. There's an image, there's a technical image. You can create these parts with respect to dimensions, and also we will create on our next webinars. I just want to thank you for the participating in this webinars, for your time. It's a long time for a webinar. I hope it passed good for you. And I have a question. Do you have tutorials, videos for amateurs? Yes, we are. From these webinars, knowledge points, you can have access. Also, Autodesk have a different types of tutorials on particularly Fusion. And also, if you want to check it out, Design Wagon YouTube and Instagram channel, we have different types of tutorials. And last question, in rendering, the only difficult that I found is when we import an image and we need it transparent. You can actually you can change the visibility. And after that, yeah, I already created these types of projects. If you change the visibility, you can get transparent. If you have any further difficulties about this particular project that you're working on, you can send me a mail, and I will be happy to answer. And thanks a lot.
Before I continue, we have Ben raised a hand. Ben, if you can type your questions in the Q&A chat, and Cengiz will answer for you. While we wait, I will share my screen one more time. And I just want to remind everyone, basically, for those of you that are not using Fusion, you can go to the Autodesk link education that you are seeing right here. And from there, you can access the software and basically leverage the software for your technical knowledge to put it in practice. Besides Fusion, there are a lot of other software that you can find there as well. As Cengiz mentioned, so the next webinar is Mechanical Simulation Analysis Application, which is scheduled for 10th of January. So hope to see you there. Just to confirm that a recording will be shared with everyone who joined this webinar. And if you have any questions or you want to share feedback, please feel free to reach me out on my email, anna.sukirovska@knowledgepoint.com. That would be all from our side. Do we have a question? Any last question we can answer before we conclude this webinar? Or if you don't feel like typing it now, as we mentioned, you can reach out to our emails and we will answer it then. Thank you so much to everyone for joining. Have a lovely evening and see you on the next webinar.
See you on the next webinar, everyone, and have a nice evening. See you.